Welcome. I am Mark Dundas, and this is TechWorks MCIP series, Training Part 3, Wiring and Networks. Little bit of housekeeping before we get started. Again, if you've taken the other two parts, you've already heard this before, but this part, specifically part 3, is more tied to the installer and the system designer because we're going to start talking about nuts and bolts and how to hook them together. We assume that you've already watched the other two parts and you have a basic understanding of what an intercom is. This is a 4-part series. This is part 3. If you haven't taken part 1 and 2, you should back up and take 1 and 2 before you take 3. This is system wiring. The system guide is available online for the MCIP product family. Before you begin, I highly recommend you pause this presentation, go back to the website, under the product tabs, system guides, MCIP systems manual, download it and keep it handy. There is also a presentation guide handout available for this. Download that as well. Take notes as you go along. Certificates are available for people that take all 4 parts of the training. We're happy to send you a signed certificate of authorization to represent TechWorks working on the MCIP product. Another bit of brief review. Let's make sure you know what an MCIP is and why it's used. What matters in public safety? It's reliable intercom performance with integration. They need the intercom to work. That's first of all. It has to always perform at the same level very reliably. That's what TechWorks is known for. But with integration, a lot of times systems are the capability of a system is determined by the integrator, not by the manufacturer, because it's how you hook it together. In this case, we made it so easy for you to hook this system to an integrated control network, and the intercom still stands alone and performs at its highest level. Very critical. This is used in detention, cell to guard communication, police stations, sally ports, etc., courthouses, security desks, interrogation, isolation cells. In healthcare, reliability is assumed. Hands-free articulate audio becomes the critical factor. This could be in prison infirmaries because they don't want to enter the room. They want to be able to hear somebody even if they're mumbling. Isolation rooms where you have to keep someone isolated because of either infectious disease or some other reason, and you have to be able to talk to them as clearly as possible. They may have a mask on, oxygen and that type of thing, so that it's hard to understand them. So articulation, hands-free audio. These people can't touch a button. Operating room, same thing. You got sometimes high noise environments where the doc can't touch anything, but they have to talk to someone outside of the operating room. Observation rooms. These could include sleep labs, behavioral health environments, child development. And then there's chemotherapy sterile compounding, which is an extremely challenging environment with very high noise in the technical area where it's a clean room. And then outside of that clean room, you might have one or more pharmacists instructing and supervising those sterile compounding technicians. So again, very critical in very challenging acoustic environments. That's what matters to healthcare. System wiring. This is what this section is all about. So the MCIP system is basically a TCP IP network over category cable. So all of these are Cat 5, Cat 6. We prefer Cat 6 in all cases, but Cat 5 will work, especially out here on these analog ends. Cat 5 works. When you're using the NC2 product, it is category cable even to the remote stations. Here, this category cable is not being used for TCP/IP, it's being used for analog communication. We'll talk more in detail. But basically, it's a category type of installation with a couple of exceptions. When you're wiring an integrated system, you have your touchscreen door control, whatever control system out here, and it's on its own network. And then it has a connection to the TechWorks network, which is totally separate. Okay? Two separate networks, separate switches, separate everything until this one connection. We want our own network to prevent latency. We don't want any delays. When you're talking in a cell, we want it to come out of the operator's console. When the console button is pushed, we want it to come out of the remote cell speaker as if it were a hardwired system. That is the magic of the TechWorks MCIP intercom. It acts like a hardwired system. So don't share networks because you'll get latency. We want no delays. Single or multiple IP integrations. What does that mean? You choose. Well, you can have your system have its own control interface in each building and connect to that local network, or you can connect your network all together and have one single point of connection for the entire property. That's up to you. The other thing is, if you're doing your own touchscreen development, the integration to controlling this intercom is super easy through API commands. Your icon through the network tells this system to talk from here to here, all through commands. If you haven't heard, TechWorks and Omron over a year ago got together and put together a very wonderful interface. So if you happen to be using Omron touchscreens and their control system, you come off of their server, not off of the switch, but off of their server into our system. And when you're putting together your icons in their touchscreen, they actually have a help screen to help you with the APIs. So makes it very easy to do this integration. Very easy connectivity, very easy programming. When you get into a large system with multiple servers, so instead of a host here, you have a server here and a server here and a server here, you're going to have your network all wired together and you get to choose where you make the connections. So you can have one server per building for redundancy. So this building here stands alone. If this network infrastructure in your WAN goes down, this building still functions. This building still functions. This building still functions. However, if you've got all of this infrastructure tying these servers together, this guy over here can talk to this guy over here. You decide who calls who by how you program it. When it's operator to operator communication, you even determine how that call is answered. So if this operator over here calls this operator over here, it can be auto answer, meaning this connection is made without this receiving party touching anything, just as if you'd called this cell over here. X just exactly the same. However, if you have a privacy concern, this operator can have to answer that call. So this person can't eavesdrop on this operator. They call, make a request, this console rings, they have to answer it like they were answering a remote station, and then both parties have to push their push to talk button to activate their microphone. That way, nobody can inadvertently hear the other party. With this architecture, you can tie 32 networks together. So you could have 32 of these networks all tied together for a total of 1,000 operators, 1,024, and 16,384 remote stations, all on one network. So that this guy over here can talk to this guy over here. MCIP MSI, what the heck is that? Microphone speaker interface. We talked about it in the previous presentation. This little box here is a little sound system in a box. You can do the same thing pretty much with a rack full of equipment, but this makes it super easy, and it ties to the MCIP control consoles. You have a microphone speaker interface, which is this little box right here. It can connect to a professional microphone. It has 24 volts phantom power to power this microphone, and it's got built-in equalization to tune it to the room. And it also has automatic level control. So if from a whisper to a shout, the level comes out of this console all the same. You're not having to constantly ride gain on the system like you were some kind of a sound operator. Whatever's coming out of this microphone comes through this network all at the same level, thanks to that automatic level control. 25 volt, 10 watts of speakers. That's enough to put about 4 ceiling speakers in a fairly large room and make sure everybody hears. You can also add foot switches. You can have a foot switch for call-in, meaning the people in this room can step on a switch and call the operator, just like pushing a button. You can also have a foot switch that activates this microphone. If for some reason you have an environment where you don't want that microphone live all the time, but you can't touch anything, you can give them a foot switch and turn that mic on. We also give you a really unique interface in that we give you a dome light output so that in this room, if someone is being listened to by this microphone, this light goes on to give them a right to privacy ADA compliant interface that, hey, be careful what you say, you're being listened to. This box also interfaces to our traditional CI bus products. That way you can add headsets, local operator consoles, or music and paging to any of these rooms. Basically, this is a room and you have a little sound system in this room. You have another little sound system in this room, this room, this room, this room, etc. They all come back and this operator selects which one he wants to talk to. Again, the wiring is all category 6. Just plug it together. We'll talk more about this wiring on the back end in a later slide. So on the network, first of all, it's all Cat 6 cable recommended. We recommend TIA 568B. Why? Not really because it makes a big difference to us whether it's 568A or B. Both are going to function exactly the same. We like to think, though, that if you start out thinking 568B, then everybody's going to wire the connectors the same. The one thing we have seen people do repeatedly on our hardware is one technician wires one end of the cable to 568A, the other end is wired to 568B. So let's just everybody agree, when you're doing TechWorks, use 568B, and you won't have those problems. Everything on the network side is industry standard connectivity, meaning we're using RJ45 connectors. All you got to do is terminate your cable right. Some devices are PoE, so just bear that in mind. Doesn't change the way you wire them. Just bear in mind that some of them we're going to provide power. Most devices, however, require a local 24-volt power supply, which is sold separately from the product. This is kind of the network ID switch is a rotary switch in every box. It's kind of a crossover between installation and programming, but it's typically left up to the installer because he's the guy putting the device in the box or in the rack or wherever. So every box has a network ID switch inside of the unit. So you have to take the lid off and find the rotary switch. There's also a shift jumper in there. This is all part of the installation process. So think of it while you're doing the wiring. Save time later. These rotary switches set the ID of the box from 0 to F, where A is 10, B is 11, 12 is C, D is 13, E is 14, F is 15. There's also a shift jumper inside of every box. Sometimes it's called the option 1 jumper. The manual, again, will identify that for you. But basically, this adds 16. So you go 0 through 15. And then if you want to do number 16, you put the shift jumper on and 0 becomes 16, 1 becomes 17, 18, 19, 20, all the way through F becomes 31. So 0 through 31 are your ID settings. ID switch settings determine the IP address of each box. This is critical because you're working on a private network with static IP. And this is how the host/server knows who's connected. Because every host and server, the host port on the server, has the network ID of 172.30.100.2. Okay? That's on your TechWorks MCIP network. Got to have one of those somewhere on that network because that's going to do all the work. The MCIP ODCs, when you set their address, 0 is equal to an address of 172.30.100.20. The ID 31 corresponds to 172.30.100.51. So 20 plus 31 gets you to 51. So in between, you've got ODC 21, 22, 23, 24, 25, 26, etc. In the MCIP 116, 0 through 31 corresponds to IP address 172.30.100.84 through 115. And in an MCIP MSI-11, 0 through 31 equals 172.30.100.116 through 147. In this way, when these things are plugged into the network, the host sees this and says, oh, that's an ODC. It's this particular ODC, and it sends the programming that you stored in that host. That's how, if you have to hot swap a box in a service call, it gets its programming from the host, is via that static IP address that you assign through the rotary switch. It's always a good idea to wear static protection bracelets when you open up a box. If you don't have to open up the box, don't worry about it because the case is going to protect it. But when you start touching that circuit board for any reason, you should have yourself grounded with a static bracelet. Just always best practice. Let's talk about an MCIP ODC and its connections. So all of the connections for the MCIP are inside the case. The reason for that is to make as certain as we possibly can that this thing doesn't get inadvertently disconnected. They have to take out some tamper-proof screws to get at the IP connector and the power if you're using a separate power supply. So to remove the cover, you take the screws out of the side, and then you tip the cover forward. So see the cover's over here, the console's back here. You run your Cat6 cable, and if you have a local power supply, run it in the back through this grommeted opening and plug it in to these connectors here. There's your TCPI connector right there. If it's PoE, it doesn't have a local power supply. There are 2 mounting holes in these boxes. This is to screw this thing down to the countertop so that nobody picks it up and yanks it and rips it off and tries to damage it in some way by throwing it across the room. It's always a good idea, if you are going to put screws in these holes, disconnect your power and data before you do it to make sure that you don't drop a screw on any of this open circuitry. You don't want to have the experiences of a zap and you've ruined the console. Over here is the network ID switch. This is your rotary switch where you select 0 through 15. And over here on the side is your option 1 switch. You want that to the on position if you want to select with your rotary again, 16 through 31. Again, when you have the lid off of this box, static ID or static anti-static bracelets are a very good idea. You should be grounded before you touch anything.
Let's talk a bit about the MCIP 116 connections. All of our system components employ RJ45 connectors for a couple of different purposes. You'll see on the back of the 116 an unshielded black RJ45 on the left. That's for connection of PA bus devices, such as a PA402 paging amplifier. So in general, you can use the 20-watt amplifier that's built into the 116 to do paging. However, when you get something connected like an exercise yard and you need more power, you might need to connect an external amplifier. That's where you do it, right there. Out of that PA bus connector comes not only your audio, but also the control, which tells the PA402 when the 116 wants to talk. So all of that interface is held in that one cable. We'll talk more about that in detail on the next slide. On the right-hand side, you'll see a shielded RJ45, and that's your TCP/IP connection to your TechWorks network. Either application assumes that you're using a Cat6 patch cable and that your wiring is to the standard 568B. To the right of that is your power connections. You have both a Euro connector, which is wired as the first screw is 24 volts DC, the second screw is common, third screw is chassis. For those of you that want to do a chassis ground, that gives you access hardwired to that metal case for whatever purposes you need for galvanic grounding. There's also, you can't quite see it, but buried in there is a barrel connector for a standard TechWorks 24-volt power supply. You can just plug it in right there. All station wiring is done via a 4-conductor compression clamp connector. The wires are on 0.1 center spacing, and they are big enough to handle anything from an 18 down to a 24 gauge wire. Typical speaker wiring for this connectivity is a shielded twisted pair for the audio, plus 1 conductor outside the shield used for call-in. The call-in wire is an extra conductor that's dedicated for just your push button. The shield is connected to ground or common only at the amplifier or control module end, not at the distant remote speaker end. So your connectivity is typically your red wire goes to your speaker plus, which is the first pin. Your black wire goes to your speaker minus, which is the second pin. The third pin should be your shield or common wire. And the fourth or rightmost connection on the connector is your call-in switch white wire. When you get to the distant end, oh, and by the way, I forgot, you need to strip these wires. This is not an insulation displacement connector. You have to strip these wires back about a 1/4 inch before you poke them in that hole. That's another key thing. On the distant end, you've got your connection again for your call-in button as your white wire outside the shield, and then your shield should only connect to that button. On that distant end, don't let anybody tell you to connect that to the box or conduit or anything else. That will cause hum. You don't want that. You only want to connect it to the button. Then you connect your red wire to your speaker tap and your black wire to your common on your transformer. Your speaker tap is typically going to be 1/2, 1/4 watt, something like that. You will almost never need 1 watt. 1 watt is a lot of horsepower inside of a small area like a cell with these highly sensitive small speakers. If you ever make a mistake on these connectors, there is a slot on the top of the connector where you can push in a 2 millimeter tech blade screwdriver and release the clamp and then pull your wire out and move it around. So if you get something in the wrong hole, it is possible to disconnect it and move it around.
If you're connecting an external paging amplifier, you need extra power sometimes because inside of this box, the MCIP116 has 20 watts, which equates to approximately 1.25 watts per port. That's enough for stations and cells. However, if you got an exercise yard or something like that that's got a lot of speakers and 20 watts isn't enough to accommodate all 16 ports, you can add an external paging amplifier to take this up to 40 watts real quick with a PA402, and it runs on the same power supply that powers the 116. So for connectivity, you plug the PA bus connector, this RJ connector right here with a Cat6 patch cord, into the PA bus input on the PA402. And then you connect the output, the 25 volt, 40 watt output, to this 25 volt amplifier input on the back of the 116. That's all there is to it. Pretty simple. The thing you got to remember is you got to tell the system that it's to use an external paging amplifier and not the internal one. So this you'll get covered in the next section, which is programming, but this is where this comes in. When you are programming this 1160, you have to tell it that it has that PA bus amplifier connected by checking this box, external paging amplifier. If you're using an MCIP116 NC2, all the wires of an NC2 are the same as a 116, a plain 116, except the station ports. These station ports are 16 RJ45 connectors with 2 lights on them. They are analog, not TCP/IP. They use standard Cat5 or Cat6. Again, we always prefer Cat6 if we can get it. The station connecting wires are not TCP/IP. Pin 1 is indicator power. Pin 2 is call-in number 1. Pin 3 is indicator output. So if you had lights on this, your indicator light output is going to be on connection number 3. Then comes speaker plus and minus on 4 and 5. That's your blue, white, white, blue pair. Then pin 6 is your second light output, and pin 7 is your second call button. And last but not least is your power common, which is critical to powering all your devices. So when you're wiring an NC2 system, you've got your traditional network, just like everything else, all hooked together with your Cat cable. But over here on the back end, you've got category 5 or category 6 going out from the 116 to your dome light, then to your station. So everything is Cat 5, Cat 6 to each room. And then again, from station to station, your connectivity from one station to the next, if you're using a separate station for a separate call point, is again just a Cat 6. Plug in, out, in, out. So here's your stations. All of your MC stations have a RJ connector labeled station in, station out. The MC NC2 VPSS-2G has a local cancel button. Well, what does that mean? It means you're not going to have this screw terminal up here because you got a local cancel. You're not going to have remote cancel installed. However, you are going to have these jumpers on the back where you get to determine how this station calls in. Does it call in as a normal call, or does it call in as an emergency call? On the back of the remote cancel version of this, now you see there's no button here. We don't have a cancel button anymore. All we have is a lighted call button. Then you get these screw terminals. That's what determines how this station can be canceled. Now, you can also cancel it by hanging up with the operator. When the operator hangs up, call's disconnected. However, if you want a key switch, this is where you would hook it up. You have 4 terminals, switch plus and minus, and light plus and minus, so you can drive a remote LED indicator if you want to. The MCVPBL is just like the speaker stations, except it doesn't have a speaker. Again, it's got jumpers on the back. You determine if this is an emergency call or a normal call, and you can have it in a local cancel or a remote cancel, very similar to the speaker station. If you are doing remote local cancel, meaning somebody's going to peek through the window but not enter the cell, you can use any contact closure. We offer the key switches to present a contact to cancel the call. You can use a lighted push button like our good old VPBL. That's just a push button with a light on it. It'll light up if there's a call in process, and it's essentially the same thing as moving that cancel button that was on that speaker station out to a remote plate. We make 2 flavors of dome light available. The MC NC2 DL22 is a 2-color dome light, red and white. It has 2 station ports on the back, so you can come out of your 116 into your dome light, out of your dome light, and onto a local station. You can do that from a second speaker port if you have 2 beds in a room, and then either normal call is going to light the white and any emergency call is going to light the red. These are RJ45s, just like everything else, station in and out. If you need to have 4 beds in a room, each with their own talk path, you can take 4 ports on your MCIP 116 and take them out to the room. This gives you 4 voice paths per room. Each voice path has 2 call levels and 2 light outputs. What's going to happen here is there's 8 RJ connectors. So you come in station 1, out station 1, in station 2, out station 2, in station 3, out station 3, in station 4, out station 4. Whenever station 1 is active, the red light will light. Station 2 will be yellow, station 3 will be green, and station 4 will be white. The MCIP MSI 11 has a lot of connections. It's got a lot of options. You got your speaker going out to a 25-volt ceiling speaker. We recommend at least a 18-gauge twisted pair here. Speaker plus, speaker minus. If you are using a local microphone, which almost always is the case, you should use a twisted shielded pair. That shield has more purposes than just a ground wire. It provides phantom power to your microphone. This is true also if you decide to add a talk switch out there, a push to talk switch. We recommend the exact same thing, a 22-gauge twisted pair plus 1 conductor, kind of like your speaker wire in a standard cell. This gives you a talk control to the shield. But again, your shield has to be there to provide for power to a condenser microphone. If you want to put a remote call switch in there, again, it doesn't need a lot of gauge. 22 gauge is fine, 2 conductor. CI bus in is a category 6 patch cable. CI bus out is a category 6 patch cable. If you are going to provide a remote dome light to tell someone that they are being listened to, then you should use a 3 conductor number 22. So you got plus, minus, and the switch control or mic on. Next to that is a little mic on local indicator, which tells you when that connector is active. Next to that is your network ID switch. So you don't have to take the lid off of this box to get to the network ID because this typically isn't used in high security environments. We decided to make it so that it was easier for the technician and brought it out to the back panel. The jumper, however, to shift to the upper 32 is a jumper inside. The Ethernet connection, as usual, is a RJ45. And your power, you have two of your 3.55 barrel connectors, the 24-volt power supply, which this is only drawing about 1.5 amps, so not a lot of load there. MCIP MSI 11 has many jumper options, so you have to take the lid off. Once you take the lid off, you will see all these jumpers that are marked in red. The address shift jumper to add 15 to the address rotary switch on the back is P3 back here in the upper left-hand corner. So to the right is 0 through 15. If you move it to the left, you get 16 through 31 when you turn the rotary ID switch. Option 2, which is P4, is not currently used for anything. P2 is to force the bootloader. What does that mean? Well, if you got this box locked up, it wouldn't allow you to load any new firmware, and you couldn't remotely correct the problem. So we threw this jumper in there in case you do something and get this box locked up. We can make it force to the bootloader, then we can load new software to it. Hopefully get you out of trouble. P12 is for phantom power to your condenser microphone. It's just an on-off jumper. Why would you want that? If you're using a dynamic microphone, you might not want phantom power because you don't want the pop when you plug it in. Gain range, what does that do? Well, that turns your microphone input down by 15 dB. That's used in very loud environments when you don't want all the sensitivity of that microphone. It's just too hot. You need it a little lower so that you have some kind of gain control. 14 and 15 are your mid and high cut jumpers. Those are used to roll off the upper and lower frequencies of your microphone so that if you've got a rumble in the room or something like that, you can adjust it. CI bus slave connector source and CI bus master connector source. What those do is they determine what comes out of this master connector and what comes out of this slave connector. Now, what do I mean by that? Do you want your microphone coming out of this connector? Well, that's what this jumper does. It determines if this microphone comes out of that connector. The other connector says, if I've got something hooked up over here like headsets, do I want that coming out of here or do I want it to stay local? In other words, are those headsets only supposed to talk to this speaker or this operator console? Or are they supposed to talk to something else in the system? So you can have this connector isolated from this connector by these top two jumpers. These down here in this corner determine what comes out of the speaker. Do I want the signal coming from the headsets connected to this connector coming out of the speaker? Or do I want whatever's connected to this connector coming out of the speaker? Software option jumpers, we have several software options already built in and room for more. If there's no jumper, or in this case, the jumper is in position number 5, because 5 isn't currently used, the default of this unit is it's bidirectional streaming audio, no privacy tone. What does that mean? That means you plug it in and whatever comes in this microphone goes out this TCP/IP connector to the operator. Whatever comes from the operator turns around and comes out this speaker port. It's just straight in, straight out. However, if you move this jumper to position 1 here at the top, it becomes a push to talk, activates the microphone. The microphone will only be on when there's a contact closure between shield and that control wire. If you put a jumper in position number 2, you will get a privacy tone, letting the listener know every 10 to 20 seconds that they are being listened to. So there will come a beep out of the speaker saying, hey, somebody's listening to your microphone. Jumper 3, 4, and 5 are currently not used. So at the moment, we ship it with the jumper in position number 5, which is just a parking lot for us. It's just an easy, convenient place because the CPU doesn't pay any attention to it. Microphone wiring, whether it is a shotgun microphone or a hidden microphone, makes no difference. It has to be on a stranded, twisted pair with a shield. The twisting of the wire is very important. It's what keeps the EMF or hum out of the wire. That means it has to be twisted to audio twist, 1 twist per inch or 12 twists per foot. The shield has 2 purposes. It's for static protection, meaning pops, clicks, that kind of stuff. But it's also the ground for the phantom power to these condenser microphones. So without it, the microphone won't even work. It doesn't have power. The gauge really doesn't matter. You can use just about anything as long as it's bigger than 22. You'll get enough out there to drive your phantom power. Good connections are always extremely important. The reason is microphone signals are very, very small. So the worse the connection, the sloppier you make this connection to the wire, the more you're going to have problems. And the other thing is try to keep your microphone runs below 300 feet. The longer you run that cable, the harder you're making this little tiny signal from the microphone work. 25-volt speakers. We recommend an 18 gauge stranded twisted pair. This is always good practice. Audio twist, again, 12 twists per foot. No shield. You don't need shield. You're not going to hook it up anywhere. There's no place to hook it up. And we don't need the capacitance on the speaker line. We don't want anything like that. Gauge matters because now you've got a load out there. You've got 20 watts of power out there sometimes, or 40 watts even in some cases. So you need enough horsepower, enough gauge of wire to get there. That's determined by load and distance. Good connections always matter. They're not as critical as with a microphone signal, but they still matter. And again, try very hard not to exceed 300 feet. It's not that you can't. You can cheat if you really know what you're doing, bigger gauge of wire, et cetera, et cetera. But keep it under 300 feet and you won't have to learn much more. Again, that pretty much does it for wiring. It's pretty simple. There's not a lot of things you need to know. There's a lot of tools available online 24/7, 365 at TechWorks USA. Again, there's all kinds of help for different professionals. We're happy to help with design and quote assistance. For tech support, it's always better to email us. Get the training. Keep an installation manual handy. We're here to help, but you're your own best help. The more training you have, the less you're going to need us. Call us if you need us, but send us an email. I'm much more reachable by email than I am by phone. Online training and certification. We are having such great results from those of you that have taken the time to get the training. You're not calling, not that we don't want to hear from you, but we hear about your success. We don't hear about your problems because they pretty much go away. TechWorks products are pretty simple. Get the training and your questions will be a lot less. Help us get the rest of your staff trained, because the more your salespeople watch part 1 and 2 of these training videos, the better they are at getting things right up front. Your sales estimators, engineers, those people, and your field techs, they should take all 4 parts. They should get knowledge of what it's going to take to get this thing installed and programmed.
Certification. In order to get a certificate of completion and recognition as an authorized TechWorks applications person, we require that you take and pass all 4 parts of the test. Then we grade it, and if you pass, we will be happy to send you a signed certificate as proof that you've taken the time to do this. The submit button. We hear that the submit button doesn't always work on the bottom of those tests. The problem is an interface somewhere between your browser, Adobe, and your email client. So, for instance, that submit button is denied the access to create an email. That's what's happening on your computer. It's beyond our control. It's somewhere between Outlook or Gmail and your Adobe on your desktop. If it doesn't work, don't sweat it. Just save it to a file, name it with the test results for the applicable section, and send it to info at techworks-usa.com, or go to the website under contact us. If you forget the email address, just fill out the little form and attach your test to it. Either way, it gets to Kim. She is info at techworks-usa.com. She will grade your test. She will get back to you if there's been any problems or you haven't passed a section. She'll help you get through it. And then we can get you a certificate to prove that you've taken the time to do this. That pretty much does it for part 3. Next up is part 4, programming and API control. This is a biggie. This is where the magic happens. And so please take the last portion. It's the most important. It determines how your system is going to function. Thank you again for your time.